All right, this is the last of the key sections for Module A. We do have one more, but it's more of an introductory material type thing. So in this section, we're going to talk about point-slope form. In this particular presentation, we're just going to review the basics of point-slope form and some basic problems involving this. Okay, so far we have looked at slope-intercept form, and we always like our answers to be in slope-intercept form. Now we do have one other form that we have when it comes to linear equations, and that is point-slope form. This is a working formula, meaning that we're going to be given some information and then we're going to plug it in and rewrite it. Your final answer will never be written in point-slope form. We will convert to slope-intercept form. So point-slope form, this is the equation y minus y1 equals m times x minus x1, where m is our slope and x1, y1 is any point on the line. Now we're going to look at two different types of problems involving point-slope form. The first one is just basic information if you're given a slope and a point. But sometimes we're going to be given 2 points, and so if we are given 2 points, the first thing we want to do is find the slope, if not provided, using your slope formula. From there, you want to plug in the slope and the coordinates of one of the given points into the formula. And then, as I said, we always want our answer in slope-intercept form, so we are going to want to solve for y. In order to do that, we want to distribute to clear the parentheses, and then we're going to use the addition property of equality to isolate y. Okay, so let's go ahead and get into some examples. Example A. We are given a point, we are given a slope. So this is going to be our base case, and this is going to be probably the easiest example that we will see. So the first thing that we're going to do is we're going to plug in to our formula. Here's our formula again. And so if we plug in, we get y minus y1, which is 1, equals m, which is 2, times x minus x1. We get minus negative 3. I'm going to go ahead and, whether you choose to actually write minus negative 3 or just convert it to a plus 3, that's up to you, but this should be x plus 3 inside our parentheses. Okay, so then from there, we said that we want to solve for y. So I'm going to distribute to clear my parentheses. We get 2 times x is 2x. We get 2 times positive 3 is plus 6. Last thing we want to do in order to get y by itself is get rid of the minus 1. To get rid of minus 1, we add 1 to both sides. So our final answer is y equals 2x plus 7. So that's our base case. Let's go ahead and step it up just a little bit. Let's look at one that contains a fraction. All right, so we have our x1 and our y1, and we have our slope. So if we go ahead and plug into our formula, we get y minus negative 6, I'm just going to write that as plus 6, equals negative 1/3 times x minus x1, or 4. Okay, so from there we want to go ahead and simplify. First thing, or solve for y. So the first thing I want to do is distribute. We get negative 1/3 x. I want to know what is negative 1/3 times negative 4. Remember, with fractions, we're going to rewrite the 4 as over 1. I cannot cancel anything, so we're just going to multiply straight across, and we get positive 4/3. All right, last thing we want to do is we want to subtract 6 from both sides. I'm going to come off to the side and do my work. We have 4/3 minus 6 over 1. We need an LCD, and our LCD is 3. So the second one, I want to multiply top and bottom by 3. So we get 4/3 minus 18 over 3. And if we go ahead and simplify that, that is negative 14 over 3. So my final equation is negative 1/3 x minus 14 over 3. One thing to note, and we'll see it in the next slide, is if you are working with fractions, you should always report your answers as fractions. If you're working with decimals, it's okay to write your answer using decimals. So for this one, negative 14 over 3, I'm just going to leave that in fraction form since we did have a fraction in our original problem. All right, so these are some base case examples of our point slope form. So let's go ahead and step it up just a little bit. The other type of problems that we're going to encounter are problems where we are given 2 points. And we'll play around with these more when we get into our application problems in the next presentation. But let's go ahead and just play around with these. These are just some basic ones. So example C, we want the equation of the line through 3, 6, and 1, 3. My first step is to find my slope. So we need to bring back our slope formula. We want to subtract our y coordinates over our x coordinates. So if we do this, I'm going to do 3 minus 6, my y coordinates, over 1 minus 3. Remember that it doesn't matter which point you identify as x1, y1 or x2, y2. You can identify them however you want. And I'll talk about why that's important in just a minute. Okay, so now we go ahead and we simplify this. We get 3 minus 6 is negative 3. 1 minus 3 is negative 2. And if we simplify that, I can cancel out my negatives and get positive 3 over 2. Now the main reason that I want to emphasize that it doesn't matter which one you label as x1, y1 and which one you label as x2, y2 is when we get to the second part of this problem, which is plugging into our point slope form, note that it doesn't matter which point you pick to plug in. So it's up to you. Which one would you rather work with? Personally, I like my 1, 3. My numbers are a little bit smaller. Maybe it's going to be a little easier. Who knows? So if we go ahead and plug in, we get y minus 3 equals 3 over 2 times x minus 1. All right, so we plugged in. We're going to go ahead and distribute. We get 3 over 2 times x minus 3 over 2 times 1 is minus 3 over 2. 1 times anything is itself. So negative 1 times anything is negative itself. And then from there we can add 3 to both sides. We get y equals 3/2 x. I'm going to come off to the side and do my fraction work. My LCD is 2, so I need to multiply my second fraction by 2. We get 6 over 2, and now if I go ahead and add this, I get positive 3 over 2. So I'll bring that back to my equation. And so our final answer is y equals 3/2 x plus 3/2. All right, let's go to example D. Example D, the first thing we have is the same thing. We need to find our slope. So if we go ahead and plug into our formula, I'm going to do my y values. So negative 3 minus 2 over my x values, we get 1.6 minus negative 0.4. Minus negative 0.4 will become plus 0.4. And if we go ahead and simplify this, we get negative 5 over 2. Now on this problem, since we are working with decimals, I personally don't like combining fractions and decimals in the same problem. So I'm going to go ahead and rewrite my slope as a decimal just to make it a little bit easier in terms of our computations. Okay, so now that we have our slope, we can go ahead and plug back into our point slope form. Let's see here, which point do you want to work with? I'm going to work with the first one in this case. Again, it does not matter. If we go ahead and plug in, we get y minus, y1 is 2, equals m, negative 2.5, over, or times x, minus negative 0.4 becomes 0.4. If we go ahead and distribute, we get y minus 2 equals negative 2.5x. And you can use a calculator for this. 2.5, negative 2.5 times 0.4 is equal to 1. So we get minus 1. Finally, we add 2 to both sides. And we get y equals negative 2.5 x plus 1. All right, that takes care of example D. Let's look at one more. Let's look at example E. Again, we're given 2 points, so let's go ahead and start by finding our slope. If we go ahead and plug in, I'm going to do my y-coordinates first, 4 minus 0. And I'm going to do my x-coordinates. Remember, we have to do the same order, so I'm going to do 0 minus -3 or 0 plus 3. If we simplify, we get 4 over 3 for our slope. Now for this particular problem, you do not have to use point-slope form, and you should always check this before you start getting into all the complicated work. This one we can actually take a shortcut, because this right here is a y-intercept. So for this problem, you can actually use slope-intercept form. You don't have to go through all the work involved with point-slope form. If you can identify one of your points as a y-intercept, you can go ahead and just use slope-intercept form. We should get y equals 4/3 x plus 4. When we get into the application problems, that's something that you definitely want to look out for, just so that you don't have to work with really complicated problems. Alright, so that takes care of the basics of point-slope form. In the next section, we're going to look at a couple of application problems.